Okay, so this is our first mini lecture in a sense. I do these little mini lectures kind of on the fly, so they're not like high tech or anything like that, or anything like that. They have my flaws, my mannerisms, all that kind of stuff with it. I don't have time to script every single second out of it, and so the point comes is as you get what you get, just like if I was in a lecture hall and I was talking to you there, that's what you get, okay? And so it's not high class in any way, but hopefully you enjoy the perks. No, not enjoy the perks, but enjoy the quirks is what I should say. Okay, anyways, we're going to start off today a little bit talking about, well, what is earth science and why is it necessary? Why does it, or how does it impact our lives a little bit? So I wanted to start off with a little bit, just kind of a little humor here. I love Calvin and Hobbes, and this is a great one that's been adapted a little bit for me, in a sense, for a geologist, and talking about how geology is more of a passion than it is a job sometimes. And at least that's how I feel about it in a lot of ways. It always has been a passion for me. And so geology actually ranked about number 7 on the Forbes list of the 15 most valuable college majors. When I say geology, I think of more of just the earth science as a whole. So we're talking about hydrology, meteorology, anything that has to do with the study of the earth and how the earth actually interacts with us on a daily basis could be part of what we call the earth sciences. And there's a reason why people think that this is a very valuable major. Okay, and why we should study this topic is because it really impacts us every single day in all that we do. And so let's kind of learn about this a little bit. So if you think about it, all of our oil, our energy, comes from these natural resources in the geology and hydrology and some of these things like that actually to learn about. Okay, so the plastic for your phone, the plastic for this computer that I have here, all come from oil products. So a pencil, you have to actually get energy to actually to form that wood into that shape, right? To actually, and you have to get the metal from mining to be able to actually get that to mold that pencil in a certain way. You need to get the graphite, mix it with clay to be able to get the pencil lead. The metal you have to mine to actually get that and to actually process that. You have to, for the rubber, that's also a petroleum product. So all of these things are from the earth, and everything that we own actually comes from the earth in some way. And from the study of that earth, we get those resources and use them in our daily lives. We don't really realize it a lot of times, but that's how that material comes about. Also, there's things like disasters, floods, hurricanes, earthquakes, volcanoes. All of these are things that we as geologists study and people or scientists study so that we can help mitigate or lessen the effects of these impacts on our lives. Okay. Also, something that I study quite a bit is actually water resources. And the water that we drink every single day that nourish us and to actually give us our energy for our bodies and things like that when we need, also is something that comes from the ground, that interacts with the earth, and it's things that we need. So if you think about it here, geology has an impact on us quite severely. It's something that we have on an everyday basis. You might not realize it, but it is there, and it's something that we study for. And that's why it's so an important major, because all those resources are some things that we need. Well, why do we care here in North Carolina? Well, let's talk a little bit about that. Earth sciences actually impact us as well. If you think about it here, natural gas is something we get to fuel our lights, our power, and we potentially could get natural gas here in North Carolina. And some people are kind of worried about it because we are worried about this idea that we call fracking, where we actually break apart the rock in the subsurface to actually release gas and to be able to extract it. Well, there is a potential for that in North Carolina. It's not good enough yet for us to actually really mine it in any earnest here, but we are getting it from other places than piping it in here. So, for example, the East Carolina pipeline, they were piping natural gas from fracking from from Pennsylvania, New York area, Virginia area, all the way down to here to Pembroke. The end of the line is actually just north of campus near Prospect, where Prospect Road and 701 actually meet. That's where the actual pipeline comes. If that actually it can cause a lot of problems. We'll talk about maybe that pipeline a little bit later, but that's one that you should probably learn about, right? It's impacting your neighborhood. This is actually after Hurricane Sandy, where the impact of the hurricane actually destroyed roads, destroyed the coastline a little bit, and we need to understand how to mitigate that. Solar energy is a huge industry in our region because of the marginal lands that are here, the sun that we get, things like that. It's a good resource that we can then use to power our region here. And we are the number one supplier for solar in the state. And North Carolina is actually the number 2 state who actually employs solar in the nation. So it's an important impact that we actually do. We can get tornadoes. This is a tornado that actually occurred in Fayetteville just a couple of years ago, about 4 or 5 years ago, that impacted these communities here, destroyed many of these homes. We had a coal ash disaster up near the Dan River, where coal ash from a power plant, which we extract the coal from Pennsylvania, Virginia, those other areas, transported down, burn it for fuel. The extra ash, this materials afterwards, are left in piles lots of times, and those piles were failed and actually spilled into the river and causing a lot of heavy metals, things like that, going into the river. So that has an impact on our water supply. In our neck of the woods, we actually even have another water supply issue, where we have Gen X, which is a company down the street here called Kenmore, actually is at a Gen X spill and spilling into our local water supply, which can cause problems as well. We had Hurricane Matthew that a lot of you guys have had this, probably know about, because you maybe even got impacted by it in our local area. That actually impacts us in earth science. One of the first gold mines in North America is here in North Carolina, up near Gold Hill and Reed's Gold Mine. So there's lots of resources that we have here in North Carolina, and earth sciences are important for us to understand that impact. Okay. We as a department here, and also trying to help you guys to learn more about that. We actually have a program where we're taking students out to the Grand Canyon this Maymester. It's actually a spring class that is going on right now, but you can still sign up for it up to about mid-semester if you're interested in it. The only prerequisite is this class that you're taking right now, and if you want to do a co-requisite, I'm fine with that. So please think about it. If you're interested in it, let me know. Send an email to me, and we're going to be going to the Grand Canyon, learning about the geology of those regions, the geography of those regions, and also a little bit about some of the people, the culture in those areas as well. So just kind of keep that as a thought if you're interested in the geoenvironmental major or anything like that at all. So let's talk about a little about what some scientific thinking is. So let's start off first with the scientific method. Scientific method is not something that you guys usually think about terribly much, but it's something that we use a lot. And the definition of each of these individual ideas are a little bit different than what you maybe have thought about when you went to school yourself, or maybe what your teachers taught you as. Okay, so we're going to walk you through some of these definitions, and these are important for us to know. This is one of the highly missed questions on my exams all the time. And what the difference between a scientific hypothesis, theory, or law is. Okay, so first of all, a hypothesis is a tentative or it's an unexplained, untested explanation that's proposed to explain scientific observations. I know your text says it a little bit differently, but these are the definitions that I like to use in our class. Okay, and so a hypothesis is a tentative, unexplained explanation. Okay, so for example, if I had a pen or a pencil and I kept dropping it, and it's the hypothesis is that gravity is actually taking that down. But if I continue to test it, then it might become what we call a theory or even a law from there. So now, but theories and laws, people get confused a lot too. Now, a theory is a tested idea. It's an idea that best explains specific scientific observations. And I apologize, I'm doing this outside, and so hopefully the background noise is not going to be a problem here. It's that tested idea. Okay, for example, that's a good example here. I have this hat here, and the question is why is this hat blue, right? My hypothesis might be that this is blue because we use dyes for maybe azurite. Azurite's a mineral that actually we use often in blue for blue dyes. And so that might be my hypothesis. Now, how I can explain this for maybe a theory is I can test that. I could take a sample of this and actually look at the look at the composition of the chemical composition of it to actually figure out if it's similar to azurite, and to see if we actually got that from that. So by testing that, we can actually explain the reasoning of why this is actually the color that it is, right? And now, a theory is something that we don't know for sure. Now, there could be other reasons or other ways that this can happen, but the point comes is that tested idea that best explains the scientific observations that we see, but is yet to be disproven. Because there could be lots of other reasons why this is blue, or other things are there. For example, the theory of evolution, theory of the Big Bang theory. All these are actual theories that we have good scientific observations about, and we have yet to disprove. That's a big statement. Disproving something is a lot different than proving something. In science, we don't don't prove anything, because there always could be that one reason or one thing that could make it inaccurate, right? And so we always disprove things. And if we cannot actually disprove something, but all the evidence is suggesting that that is the right answer, that is what we call a theory. Now, some people think that when a theory becomes strong enough, it can become a law, and that is not correct. A theory can never become a law. It doesn't happen. It explains two different things. A theory actually is explaining something that happens. It tells us how and why it happens. Okay, but it doesn't tell us what happens. Okay, it explains what happens or tells us how and why it happens, but not that what happened. Okay, a law explains what happens. Okay, a law is a statement that describes the repeated experimental observations of some aspect of the universe. Okay, for example, I can go back to our idea of a pen dropping or something like that. If I drop that pen and it falls down, what that's saying here is the law is suggesting that that pen falls. Okay, it's being attracted by that by the mass of the Earth. That is the theory. Okay, the theory is explaining why it's happening, whereas the law is telling us what's happening. Okay, so if I drop my pen, it's going to fall. Drop my pen, it's going to fall. That is the law of gravity. Okay, the theory of gravity, or gravitational theory, is that mass is being attracted by the mass of our Earth, and so therefore the actual pen drops to the ground because of that attraction. Right? That's the theory. The law is that if I drop the pen, it falls down. Okay? The theory is explaining how that happens. Okay? They're different. So make sure you understand that difference. Okay? Okay. So there's lots of different examples of this. I told you some examples like theory of evolution, the theory of Big Bang theory, plate tectonic theory, lots of them out there. I just wanted to bring those up a little bit and kind of explain them to you to start us off. Okay? Okay, so when we understand, when we talk about the scientific theory or scientific method, I mean, it's something that's a long process. It's something that happens over and over, and it's this process that doesn't necessarily go in a specific order like you might have thought about when you talked about it in elementary school or middle school. It's something that we start with a hypothesis, we start to test it, and we might disprove it, therefore we have to revise our hypothesis, and then we disprove it a little bit more and more and more until we get closer and closer and closer to what actual reality is. Okay, so that would be where we consider a theory. And so just understand that they're a little bit different than sometimes what some people think about. When I say, oh, that's just a theory, that is using it in a different context. It's using it in what we call an English context, not in a scientific context. A scientific theory is something that's a really strong statement. It's something that says we have not been able to actually disprove it. That's a scientific theory. Okay? We're going to stop here for now. We do these in 15-minute intervals, and so we'll start up again with a little bit more about Earth systems in just a second.